Welcome once again to IF Oxford, and tonight's event is about dietary sugars and insulin and the fact that one size doesn't fit all. Our chair this evening, hosting the event, is Professor Leanne Hodgson, and Leanne is from the Oxford Centre for Diabetes, Endocrinology and Metabolism, which is part of the Radcliffe Department of Medicine. And the Radcliffe Department of Medicine are one of our festival sponsors. So we're very pleased to have you here today.
Great, thank you very much, Kathy. And hello to everyone. So, as it was said, my name's Leanne Hodgson. You may notice I've got a bit of an accent. I'm originally a Kiwi. And with me tonight is Eloise Cross, who is a PhD student in my group. And Sean Parry, who will show himself in a minute, is also part of my group. He's a postdoctoral researcher. So we're going to talk to you tonight about dietary sugars. And I'm going to hand over to you, Sean, because we're going to start with a quiz.
Hello, evening everyone. So as Leanne said, we've got a couple of questions to kick off tonight's talk. So there should be a poll popping up on your screen any minute, but the questions we want you to answer are: which product of these three has the highest sugar content per 100 grams, and which product has the lowest sugar content per 100 grams? Fantastic, there we are.
Yep.
As you can see, based on your answers to the questions, we have for the highest, the majority of people, 53%, said the smoothie had the highest sugar content per 100 grams. And then the lowest, it was a fairly equal split, but the sweets just nick it with 40%. So if you can flick to the next slide for me.
The lowest is actually the smoothie, Sean, so it's been said to be the highest and the lowest.
Was that the lowest? I thought it was the sweets. No. My mistake. So then to reveal the answers for you, we can see that actually the lowest per 100 grams is the Coke, which just scrapes it at 10.6 grams per 100 grams. Then we have the smoothie at 11 grams per 100, and the highest, which was the sweets, at 63 grams per 100. But this is where things start to get a little bit confusing sort of straight away. So that was highest and lowest per 100 grams, but the pack sizes for these also have a recommended serving. Now the Coke doesn't, but a can of Coke you would assume is 1 serving. So that actually makes the highest Coke the highest sugar content per recommended serving at 35 grams per can. We then have the smoothie at 16, and just scraping in with the lowest, it's the sweets at 15 grams. But it is worth pointing out that their recommended serving is 8 sweets. I don't really know anybody who I think could have the willpower to be able to stop at just the 8 sweets. So before we go on to our next little quiz and our live experiment for the evening, it's worth just going over how we actually analyze blood glucose. So we have 3 methods. So the first is to take a blood sample and then analyze this on a clinical analyzer. Now the benefits of this are that once we have that blood sample and on the clinical analyzer, you can then measure multiple things at once alongside blood glucose. The downsides are that this is quite invasive and you have to go to a GP or another clinical setting in order to do it in this way. So the other methods, which are possibly more straightforward, are a finger prick blood sample and a glucometer, and continuous glucose monitoring. Now these work sort of slightly differently. So with a finger prick sample, you get a small sort of machine like this, which fires a small pinprick into your finger. And then from the drop of blood, you introduce a drop of blood to the glucometer and it measures blood glucose. The continuous glucose monitor sits in the arm and just samples away for however long you've got it in. And Eloise will go over this in a bit more detail later. They're slightly different, as in the continuous glucose monitor doesn't actually measure blood glucose. It looks at the interstitial fluid, and that is the fluid that surrounds cells. So you might get slightly different results from a continuous glucose monitor to a finger prick blood sample. Now we're going to run a short live experiment for you this evening. So before the talk started, myself, Eloise and Leanne all took just our sort of random sort of blood sample at 7 o'clock. So myself and Leanne by finger prick blood sample, and Eloise by continuous glucose monitoring. So mine was up at 5.6. Eloise had a value of 4.3 millimoles per litre, and Leanne had 4.8 millimoles per litre. So our experiment this evening, and our next question for you, is that whose blood glucose will increase the quickest and whose blood glucose will increase the slowest. So I'm going to be drinking 330 ml of the innocent smoothie, which is 35 grams of sugar. Leanne is going to eat 19 sweets, which again, 35 grams of sugar. And Eloise is going to have a can of Coke, which is an equivalent amount of sugar. So I think a poll will pop up for you now. So again, whose blood glucose do you think will increase the quickest and who's the slowest? And in 15 minutes, we're going to sample it again and compare values. Admittedly, we were all starting at slightly different points and we're all sort of slightly different metabolically, but we tested this earlier in the week and we show similar responses. Each of us show similar responses to the foods, give or take. So I'm now going to neck my smoothie and pass you over to Eloise to talk about why we're actually talking about dietary sugar.
Okay, so we're now going to spend the rest of this talk thinking about why we actually want to talk about dietary sugar in the first place. As you've seen, or I'm sure you've seen, there's been lots and lots of news articles actually going back a really long time about sugar and about whether it's a good or bad thing for people. So there's been many studies and there's been a lot of focus on the sugar tax recently with the government putting an extra levy on any sugared products. So it's been in the media for a long time and we just sort of want to try and clarify a few things for everyone. And so to start us off, we're going to talk about what carbohydrates are, and these are our sugars. And so carbohydrates are made from monosaccharides. These are single molecules and they're little units. So they come in glucose, fructose, and galactose. And these are our single sugar monomers. We can combine these together to make slightly bigger molecules. These are disaccharides, which are made of 2 sugar molecules. So sucrose, a common sugar, is made of glucose and fructose. Maltose and lactose, which are both found in milks, are made from 2 glucoses, and lactose is made from a glucose and a galactose. And these are all commonly found sugars. So you have your monosaccharides, which are free in your blood, and your disaccharides come more from dietary stuff. We also have oligosaccharides, which are made from 2 to 10 sugar molecules, such as raffinose. This is made from a galactose, a glucose, and a fructose altogether. And we also have our polysaccharides, and these are our starch and our glycogen. So these are made from many of these little units all joined together to form bigger molecules. So all of these, when consumed, will increase your blood sugar levels. They will all be broken down, whether they're the starch, the glycogen, or the disaccharides, to form these single monosaccharide units within your blood. So they will all raise your blood sugar. And at this point, I'm going to hand over to Leanne.
Excellent. So I'm going to start talking by, Eloise has told you about all the different types of carbohydrate, and we're really going to focus on sugars. So it's down the mono and disaccharide end of it. So we have guidelines for how much sugar we should be eating to keep us healthy. And as people that work in the area of carbohydrate research, we still find these guidelines quite challenging to understand. So the recommendation that you would read would be that free sugars should not make up more than 5% of your total energy or your total calories that you get from food and drink each day. Now, what does that all mean? Well, free sugars are also called added sugars, and they used to be called extrinsic sugars or non-saccharide. There was another name, non-milk monosaccharides. So they got very confused, but now they're called either free or sometimes added sugars. So what do we classify as a free sugar? So all sugars that are naturally present in fruit and vegetable juices, purees and pastes and similar products where we have broken the structure down are considered free sugars because they're no longer in a cell intact. So another way of thinking about it is that sugar in fruit and vegetables is not considered to be a free sugar, unless those fruits or vegetables are juiced or pureed. So as soon as you mush them up and break those cells, they become a free sugar. All drinks where we add sugars are considered free sugars, except dairy-based milks, and I'll show you some data for that soon. And then the milk sugars, which are naturally present in milk, when we isolate them and make them just single units, they can be added to other products, and then they are considered a free sugar because they're not considered part of the milk product. So it's all quite confusing really about what a free sugar is. But I think more confusing is, how do you know how much 5% of your calorie intake is? So what that translates to for most adults is to have no more than 30 grams of free sugars a day. Now, if you consider a level teaspoon of sugar weighs about 4 grams. So that's approximately 7.5 teaspoons of sugar a day that we want to be having. For children up to 10 years, between 7 and 10 years, no more than 6 teaspoons a day. And for children 4 to 6 years, no more than 5 teaspoons a day. So I'm just going to show you how easy or hard it may be to adhere to these guidelines and how we look at finding these products and these free sugars. So I've got here an example of a flavored yogurt. In this case, it was Russian fudge. How do I work out how much sugar is in that and how much free sugar is in that? Well, if I look at the energy or the nutritional value on the back of the packet, you can see it tells me how much carbohydrate per 100 grams, of which there's a similar amount of sugars. So when we get given here sugars, it equals total sugars. This does not tell me how much of the sugar comes from a natural source, that is the milk that makes the yogurt, and how much is actually added. So I've put here sucrose or table sugar. How do I go and find that out? Well, we have to check the ingredient list. If there are any words on the back of the list that have the words syrup, inverted sugar, cane sugar, molasses, or anything ending in O's like glucose or fructose, and they are within the first 3 ingredients, then this suggests that the food contains some added sugar or free sugar. And here's the ingredient list of this product. And you can see the biggest thing in the product is yogurt, milk. So that's the big amount. And then we go down the sugar list. It is sugar, glucose syrup, honey, and sweetened condensed milk. So this product actually probably contains a reasonable amount of free or added sugars. If you do more detective work, another way of showing you how this looks is if I just take good old yogurt that's straight up, as it is called here, no added sugar. Is that true? So again, looking at the back of the information, per 100 grams, I can see this carbohydrate, which is around 7.2 grams, of which the sugars are 6.8. So more or less, the carbohydrate is made up of sugars. And if I look at the ingredient list, you can actually see in those first 3 ingredients, there is actually no sugars labeled. So this product contains no added or free sugars. They all are within the milk product. Just to add a bit more confusion, I thought lollies, as I would call them, or sweets, were all the same. They would all have the same amount of added sugar. And they are sugary things, but when you look at the ingredients, what I found for these 2 products, and I've taken here just some wine gums and jelly babies from a supermarket and took their information per 100 grams. And you can see they have the same amount of carbohydrate. But what I didn't realize, and this has been a bit of a revelation to me, is actually they have a different amount of sugar. So the wine gums were lower in sugar than the jelly babies. So again, I did some detective work and I looked on the back of the packet why that was. And you can see here for the wine gums that their first ingredients are glucose syrup, sugar, and then they've put in starch. And because it's starch and not a sugar, they have a lower content of sugars. Whereas for the jelly babies, there's sugar, glucose syrup, starch is further down the list, but they've also added fruit sugars, which contribute to their sugar content. So I would encourage you to read the back of labels. If you're not sure, do some detective work because things hide out very well. And I'm sure you've heard this because look, when you've heard many things being called sugars, I really think they are the masters of disguise. And there's lots of now things that hide. So all of these things that I've got in this word cloud are sugars. We've got fructose, we have nectar syrup, honey, maple syrup, palm sugar, which I didn't know existed, coconut sugar, again, another revelation to me, molasses, golden syrup, barley sugar, rice sugar, they're all sugars. And another one that's very confusing, I think, these are coffee crystals, which again is just sugar. They've got fruit sugar, which is fructose, but here I've got glucose in many different forms, liquid glucose and powdered glucose, and actually dextrose is also the same as glucose. So they hide in different ways. And I just want to say a word about fructose. So fructose is the fruit sugar. We find it naturally in fruit, and it's surrounded by cells. It's absolutely fine for us. But high fructose corn syrup is talked about a lot and has got a lot of media press, as has just fructose, because it's thought to be very bad for our health. High fructose corn syrup isn't really used in the UK, it's used more in the States, and it's a liquid sweetener made from cornstarch and fructose, and it contains water. And when you look at the composition, about between 42 and 55% of that sugar comes from fructose, with the rest predominantly coming from glucose. Now, just to put that in context, table sugar, the white crystal stuff that you have on your table and you may add to your tea or coffee, is made up of 50% fructose and 50% glucose. So 1 molecule of fructose and 1 molecule of glucose. So it's not that different from high fructose corn syrup. So what I would say is sugar, whether it's white, brown, unrefined sugar, molasses, honey, agave, palm sugar, coffee sugar. Sugar only really provides us calories. It doesn't provide us vitamins and minerals. So really, we can't kid ourselves that sugar is really good for us, but it does have a role in making things taste good and providing us with some energy. So how is it metabolized when we come to look at the metabolism of sugar? So I've just eaten a whole pile of sweets, which I don't normally do. So I'm feeling quite high on glucose at the moment. How is my body now dealing with it? And how is Eloise and Sean's body now dealing with the sugar they've just put in? So we've elevated our blood glucose, and this promotes our insulin to promotes the pancreas to release insulin. And insulin is a hormone that has an anabolic effect. It starts making things go to other organs and be utilized. Now, as this insulin comes into our circulation, into our blood, it triggers at the level of cells, so your fat cells and your muscle cells and your liver. It triggers some transporters to start taking the glucose up into these organs for utilization. So we're removing the glucose from our bloodstream and we're bringing it back down to a level that's a bit lower than after our sugar high. And predominantly in the liver is very clever because what it can do is it can store glucose, and it's called glycogen. So this is a storage form of glucose. And then when we get a signal, when we go to bed overnight and we haven't eaten for a long period of time, we get another signal because our blood sugar drops. And there's another hormone called glucagon that's released from the pancreas, and it feeds to the liver. And what happens then is the liver starts releasing the stored glycogen as glucose to raise your blood sugar so that you don't have a big low. The liver is also very clever, and it can make its own glucose from other substrates if you really need it. So metabolically, it's a very complex cascade of events that help us clear the glucose from our blood into organs where we need some energy, and it can be utilized or it can be stored for later use. The other thing I'm sure you've heard is that sugar can be turned into fat, and this does happen in the liver. So I've just shown you, this is my overview, it's a schematic. We can take our dietary sugar into the liver, we can store it for later use, or we can use it for some energy. The other thing that can happen is we actually put it into a pathway where the sugar is metabolically made into fatty acids. So we do convert sugar into fat. And the reason we do that is sometimes it's just how we deal with a big load of sugar. It's a safe way of dealing with it and getting rid of the excess sugars in your liver. When you make these fatty acids in your liver, you then make into a substance which is called triglyceride or fat, and you can store it in your liver. So that fat is stored in your liver. And if you store too much fat in your liver, you get what's known as non-alcoholic fatty liver disease. And that's associated with the risk of diabetes and heart disease. The other thing that can happen to these fatty acids when you make the triglyceride is you put them into a particle, and it's called a lipoprotein, very low density lipoprotein that's secreted into your blood, and we get then fat appearing in our bloodstream. We always have these particles coming into our bloodstream carrying fat, and when we turn on this pathway, we may get a bit more fat coming into our bloodstream. And what we don't want is high levels of triglyceride in our bloodstream, because that increases our risk of heart disease. So do all dietary sugars have the same effect on insulin? Do they all elicit the same big response? Well, we've looked at this and we've done it experimentally. So what you can see here is we've compared glucose and fructose. And the fructose says that it's very healthy because you use fewer calories as sugar. And the reason being is fructose is very sweet. So it's sweeter than glucose. So actually you need to eat less of it. When we fed our participants a meal that contains either pure fructose with some fat or pure glucose with some fat, and measured the amount of glucose in their blood, you can see after the meal containing the glucose, we get this big increase in plasma glucose concentrations. While with the fructose, we don't really change plasma glucose concentrations. And on the basis of this, it used to be added to diabetic foods because you didn't get this big increase in glucose. But what happens to insulin? Well, you can see here, when you get a big change in glucose, you also get a big increase in plasma insulin concentrations. So your pancreas has to release more to deal with the load of glucose that's come in. Whereas you didn't get a change in plasma glucose with the fructose consumption, so there's actually no real change in plasma insulin concentrations. Now, what you need to remember is this was an experimental setup. We did this in our research unit. And what I would say, because everyone tells me that fructose is really bad for my health, is we very rarely consume fructose as a sugar from a box sprinkled on things in isolation in our diets. It is typically consumed in combination with other sugars. So as part of table sugar, sucrose, as part of some of the other sugars I showed you, honey. So when you hear that fructose is really bad for you, actually, most of the times it's with other sugars also. So over to you, Sean.
So I think it has been sort of roughly 10, 15 minutes or so since we had our sweets and our Coke. So we're now going to sample our blood glucose again and see what's happening. So this is where I'm going to take my glucometer and give myself a finger prick blood sample. And I suppose where everybody gets to see me wince live on camera. And then once I've generated a small blood drop, introduce that to the glucometer. And you say, earlier, I was up at 5.6 millimoles per litre. And then after my smoothie, I am now at 6.9 millimoles per litre. So Eloise and Leanne, how are you responding to your foods? So if we go Eloise first, you were initially at 4.3.
Mine came back as 6.6.
And I was 6.4. So we've both gone up.
So all of us have had a jump of so at least 1 to 1.5, almost 2 millimolars after drinking our sweets. So we'll come back to this again later on in the talk as well. So this is a slide or a figure that I've actually borrowed from an app called Zoe, which is a lifestyle app looking at diet and physical activity and how that relates to health. So they've labeled two curves. So they labeled the orange curve, which is an unhealthy glucose response, and then the blue curve as a healthy glucose response. Now we're just using this to demonstrate concepts. So these could be viewed in two different ways. They could be viewed as sort of if you fed two individuals, a healthy individual and an individual with type 2 diabetes, the same amounts of glucose, they'd have different responses. But it could also be the same individual having the two different responses after a high carbohydrate and glucose load versus a low carbohydrate and glucose load. So the reason the orange one is labeled as an unhealthy glucose response is it has these large peaks, which results in, as Leanne said, an insulin response. So because it's a large peak, that will go hand in hand, it will be a large insulin response. And what this has a tendency to do is actually overshoot. Our body always reacts it reacts to things. It's not proactive. So once you have this large insulin response, it can actually overshoot and we get a little dip. And then our liver then has to kick into action, start producing glucose to level it out. Whereas if you have a lower glucose load, you have this sort of much more minor glucose fluctuation. And just across the day, it's much more stable. So that's why this is thought to be a healthy response. So how can we sort of aim for these healthy glucose responses and stay away from the unhealthy glucose responses? So there's a couple of ways we can do this. The first thing that's important in regulating glucose responses is the food source or the food matrix. So I've used orange juice versus oranges as an example for this. So within the oranges, the sugar, as Leanne said earlier, is contained within the cells. It's not readily available. Whereas in the orange juice, the cells have been broken down. This is effectively been sort of partially digested. The glucose is then free sugars. It's readily available. So you'll get much more of an earlier and pronounced glucose peak. It's also much easier to drink the juice of 5 oranges than to try and eat 5 oranges in one sitting. So there's differences in sort of the absolute sugar concentrations there. The other important thing is what else you consume with food. Now we're moving away from sugars for this example and focusing on pasta, which is starch. So as we have just plain spaghetti, no sauce whatsoever, not particularly appetizing. And then we have a comparator, which is a carbonara, which is higher in fat and protein, so also higher in calories. But the fat and protein will act to delay absorption and produce a delayed glucose response in comparison to just eating the spaghetti on its own. So I'll now hand you over to Eloise, who's had a blood glucose monitoring for a little while. She'll talk you through some of her results.
Okay, so I'm going to talk again about continuous glucose monitoring. And this was a technology developed for people with diabetes who struggle to control their blood glucose. And so they need to be aware of what their blood glucose is all the time. So these are developed, and the majority of the sensors take readings every 15 minutes so that someone can be aware of what their blood glucose is at the time. And here's a graph to illustrate how it's advantageous for people. So as you can see, the green line is your sugar, and you can see it goes up and down, and the red blots are when people are doing finger prick tests to look at their blood sugar. And you can see that as it's random when you do your finger prick tests, you might not notice some of these highs. And so by having a continuous sensor in, you'll be able to have a better control or sort of awareness of what your blood sugar is. And so this is really cool technology. But I've been really fortunate, and I've actually been offered a glucose sensor through various sporting means, because they're now coming into the world of athletics. And there's lots of big name people who are now trying to use the glucose sensor to their advantage to try and maximize their nutrition for performance. And actually, it's become quite controversial, and it was actually banned from the Tour de France because they think it's too much of an advantage for people. So I've actually got some data from my own glucose monitoring. I'm going to show you now. Here we are. So this is a sample, a screenshot from my data. Ignore the units because they're in American terms, not English terms, for anyone who's slightly confused by that. And so this is me first thing in the morning. I was being a bit lazy. It was the weekend. I was lying in bed. My blood glucose is fairly low. And so you can see it's fairly steady. And at the time, I was taking part in a study. So I was on a very sugary diet. So I then consumed some shreddies, some frosted shreddies, and then some white bread. And as you can see, it made my blood sugar go all the way up and then come back down quite fast. So this, for me, is actually quite a big response. My blood sugar is normally my peaks aren't that big and my troughs aren't that small. But yeah, I just wanted to show you that this is actually how we see it in real life humans as well. But interestingly, because I was on this diet for 3 days, I got to test my blood glucose after eating the same foods numerous times. So this is to sort of really hit home the point about how it's not one size fits all. So this is an example of my blood sugar after I'd had a lot of Haribos. I think I'd had 20 Haribos at this point. And so I had a big blood sugar spike and then a fairly big blood sugar crash. I was very hungry at the end and went straight on to snacking afterwards. And over the same weekend, I had another batch of Haribos. I had about 20 Haribos again here in the second peak. But this time there wasn't an exaggerated glucose response. And as you can see, I'd had a snack just beforehand. And this was another very high carby thing because I was on a high sugar diet. But so at this point in the day, there wasn't too much differences. And so thinking about why this may be, If we're comparing the situations, this first one was taken in the evening, second was taken in the afternoon, and then the first one was when I was stationary, and the second one was when I was a bit more active. And so these are sort of possible explanations as to why there might be differences in my blood sugar. But this is just to really hammer home that, like, it really depends what your body's doing at the time when you ingest all of these sugary things. It's not always the same response. But yeah, so that's just a little side note there. So I'm going to hand back over to Sean at this point.
So I think it's worth, when we're talking about dietary sugars, it's worth discussing how sugar consumption is measured within the UK. So in the UK, we basically have three main sources of information at a population level. So we have the National Diet and Nutrition Survey, which is hosted by Public Health England and the Food Standards Agency. They aim to survey around about 1,000 people per year, and that is a combination of interviews and food diaries to look at food consumption in the house. And individuals selected to participate in that survey are randomly sampled based on their postcode. We also have the National Food Survey, which was initially started in the 1940s and then rebranded in 2000 as a Family Food Survey. That takes a similar approach. So it's randomly selects households. They aim for around about 5,000 a year. And again, it looks at sort of household consumption data. So in that, the diary keeper of the house is given a logbook, and they then log all the food coming into the house intended for consumption. So you can see there with these two methods, it's looking at household consumption. So it actually might miss foods that are consumed outside of the household. Another resource we have in the UK is the UK Biobank. Now, they assess dietary intake by a modified food frequency questionnaire and a 24-hour recall. So individuals come in, they then asked, what foods did you eat yesterday? And they're given a drop-down menu. So it could be things like, did you eat bread yesterday? And then it'd be yes, and it's a drop-down menu with type of bread, how many slices, etc. But the UK Biobank also has a whole host of other measures as well, such as genetic information, other information regarding lifestyle, blood biochemistry, and it's starting to also put together some imaging. But all of these methods are subject to limitations, and there's no perfect method. So they all subject to things like underreporting, and this could be intentional or unintentional. So it could just be an individual forgetting what they ate, or if it's perceived to be a negative health behavior, they might intentionally conceal it. It could just be incorrect coding. So once this information is in, somebody then has to code it and convert it into sort of macronutrient intakes. So if there could be errors there. And also the timing of the survey is important. And this is important for two reasons. So firstly, if I ask you, what food did you eat yesterday? In my household, yesterday was my daughter's birthday, so we had a huge slab of birthday cake. However, I wouldn't eat that every day. So your diet yesterday might not reflect your habitual diet, but also the timing of the survey, and I use the UK Biobank as an example. Dietary intake was assessed when people enrolled, which is 2011, and then health outcomes are followed for years afterwards. However, the diet might have changed across this period, but you're still comparing it to that early one. So the timing of the survey sort of matters as well. And this isn't to overly critique the studies that have used these, that it's just to point out the limitations. So if we go to the next slide, please. So there's been a push recently to move away from looking at single macronutrients and their relationship with health, because people eat food, they don't eat single nutrients. So there's a group in Oxford currently working on this at present, and they're looking at food sources for free and added sugars. So they use the UK Biobank, which, as I said, is sort of 500,000 strong participant-wise, but in terms of having data sufficient for the study, they had a sample size of a little over 200,000. And when they look at average free sugar intakes as percentage of total energy, they saw that women were, their average free sugar intake was 11% of total energy, whereas men, it was 12.3%. As a reminder, the current guidelines are no more than 5% of total energy from free sugars. They also had a look at the foods that these sugars are coming from, and saw quite marked sex differences. So you can see where these are really apparent is on the added sugars and preserves and the beer and cider. And the intake of sugars in grams per day in men is considerably higher for beer and cider than it is for women. Go to the next slide, please. So the same group also then wanted to look at the effect of these dietary patterns on the risk of heart disease. So this is a study published earlier this year. And again, using the same data, the UK Biobank data, they were able to identify 2 separate dietary patterns which were associated with increased risk of heart disease. The first was a diet that was high in chocolate and confectionery and white bread and butter, and low in fruits and vegetables, so relatively sort of quite high in fat. And the second was a diet that was high in sugar sweetened beverages such as sodas, fruit juice, and just added table sugar. And then it was low in butter and cheese. So this is relatively high in sugar and low in fat. So we take it back to the beginning where there's kind of these debates as to which is worse. It's not that straightforward. And you've got to look at the whole diet in itself, and diets that are relatively high in fat or sugar are both associated with negative health effects. So I'll ask this question and then I'll hand you back to Eloise. So another quick quiz, and it's again 3 products, and it is which product has the highest sugar content per 100 grams and which product has the lowest sugar content per 100 grams. And then I will leave Eloise reveal the results to you.
So the answers are that the highest sugar is in the yo-yo bear sweets and the lowest is in the sweet and sour sauce. Which is contradictory because from the polls, you've voted the yo-yo bear sweets as both the highest and the lowest.
Sweet and sour.
Sweet and sour. Sweet and sour has been voted the highest when it's actually our lowest. So yeah, another example of how sugars are confusing and sometimes hard to tell. The thing to pay attention to here though is again the recommended serving. So here we've got our yo-yo bears as 20 grams of yo-yo bear with 8.4 grams of sugar, and then we've got the Ben's original sweet and sour, and we've got our Heinz. And so actually per serving, Ben's Heinz is actually the highest and our barbecue sauce is actually the lowest, even though our Ben's sweet and sour was the lowest per 100 grams. So here you actually end up eating more sugar than you think because of how the label's told. And so the next part of this talk, we're going to go back to our blood sugars. And so we have our starting concentrations here. I've just checked mine, and mine peaked at about 7.2 millimolar.
I had a stonking increase, which I'm quite worried about. I went up to 10.6 millimolar. So I've just about, well, over doubled my blood sugar by having 19 sweets. What did you go to, Sean?
I have gone to 8.5. So I was at 6.9 at the last measurement. I've now gone up to 8.5. And that was after 330 ml of the fruit smoothie.
Would you like to know what people predicted? Sharing the results now.
Oh, Eloise was going to win. She was going to go up the quickest, and Sean was going to be the lowest. So I actually went up the highest, but maybe not the quickest. I would say Eloise probably did go up the quickest.
Yeah, mine was already going down again by the time we took the
Yeah.
sample. Mine's already actually currently below my starting baseline. So I guess my blood glucose is probably about 4.2 now again.
And what did you go up to, Sean?
I went 6.9 first measurement, 8.5 at the second. But I
Yeah.
think it's also worth keeping in mind as well that for the purpose of this talk, that's our final measurement, whereas we could still be sort of increasing, decreasing as we go on across the evening.
So I'm just going to come to our last slide because we want to give you some food for thought. So just going back to what our recommendation is of about 7.5 teaspoons of sugar if we want to cut back on free sugars or added sugars. I just want to point out that I've given Starbucks here, but it can be any Frappuccino, that if you have just this a tall one, 350 mils of one of these, you actually exceed your sugar intake just by having one of those a day. And then the other point is there are some things that are sold in some shops and they're marketed as healthy snacks. And one of them that really is a bit of a bugbear of mine is banana chips. And when you look at the content, it's got 44 grams of sugar per 100 grams, and it's also got a lot of fat. And if you compare that to something like crisps, it's about a similar amount of fat, and crisps have very little sugar. And if you compare it to chocolate per 100 grams, chocolate has slightly more sugar, but about the same amount of fat. So again, it's going back because bananas by themselves do not have fat in them. So if you go back and look at the label, I would say always check the label. And when you look at the back of this label, you can see it has banana, but it's got coconut oil. So suddenly there's the fat content, and it has sugar added to it as well, on top of your natural sugar in the bananas. So if you are trying to decrease your sugar intake, I would encourage you to read the label. So it just leaves us to say, thank you very much. If you would like to see more of what we do, we had a collaboration with an artist, and she has come up with a photo exhibition, which is online. And she was looking at the travel, really, the journey of fruit from the tree through processing into us looking at the isolated sugars in research. So thank you.
Thank you, Leanne. We do have a couple of questions and comments that have come in. We're running a little bit low on time, but
Yep.
I'll cover as many as I can. One of them related to the continuous monitors that are being used. And why is it that those monitors are more commonly used for people with type 1 diabetes rather than type 2?
So people with type 1 diabetes have no insulin response. So type 2, people with type 2 diabetes sometimes take a range of medications. Sometimes they can take tablets like metformin to help with control their blood glucose, or they can inject insulin. But people with type 1 typically have to inject insulin. So it's more important that they really understand when their blood glucose goes up and is coming back down, so they can either eat at the appropriate time or make sure their blood sugar doesn't drop. It just gives them a better, a very good option of tracking their blood glucose over the day, particularly if they want to exercise, because they need to make sure their blood glucose doesn't drop too much. And then they can time their eating with their insulin dose better. So I had a friend who used to do a lot of finger pricking, and I can only imagine what their fingers were like at the end of it. It's amazing. So it gives them a better picture over time of how their body responds to different foods.
Is there also a cost implication of using the continuous monitors?
Yeah. My understanding there is for buying the sensors is not very cheap. So that is, I think, accesses and the cost of them. I don't know the exact cost because I'm not a doctor, but I know there is a cost implication. Hopefully they will become more available and better, more accessible.
They're trying to develop a system called an artificial pancreas, where someone will wear a glucose monitor and at the same time have an insulin pump. And so the idea is that you can get these synced up so that it will feed back without someone with type 1 diabetes actually having to measure their own sugar. But yeah, it's expensive technology.
Yeah.
Indeed. Well, we are now running beyond our allocated time, so I am going to draw this session to a close now. All that remains is for me to thank Leanne, Sean and Eloise for an interesting and entertaining session this evening, and to say thank you and good night, and see you at the next event. Thank you.